Dear students, the lesson number 5 of the Mathematics 1 book of the Standard 10 of SSC Board, content practice set 5.1. Now, in this practice set 5.1, first question is given to you, and that is find the distance between each of the following pairs of points. Now, points are given to you. Point A, coordinates of point A is given x coordinate 2, y coordinate 3. Point B is also given coordinates of point B, x coordinate 4, y coordinate 1. So here we have to find the distance between point A and point B. So here we can say that let A coordinates x1, y1 and B coordinates x2, y2. So therefore x1 is equal to 2, y1 is equal to 3. Then x2 is equal to 4 and y2 is equal to 1. So here we get the values of x1 and y1, x2 and y2, which we are going to use in our distance formula. Did you get this point? Yes sir, no sir? Now here we just write down here we can write down the distance formula. So by distance formula, we can write down distance formula. By distance formula, distance AB, distance A to B, A comma B is equal to square root of x2 minus x1 whole square, x2 minus x1 whole square, plus y2 minus y1 whole square. This is our distance formula. Now here we have x2 as 4. So first bracket we can write down 4 minus 2 whole square plus y2 is 1. 1 minus y1 is 3. 3 square. So as a result, here we get 4 minus 2 is equal to 2. So square of 2 plus square of minus 2. 1 minus 3 is equal to minus 2. So square of minus 2. So here under square root, 2 square is 4. And again we have minus 2 square is also 4. So here we have 2 times 4. So we can write down 2 into 4. Here we can write down 2 into 4. Okay. So here we got 2 times 4. Square root of 2 into 4. As we know that square root of 4 we have 2 and square root of 2 is under square root 2, 2 root 2. So here we get answer 2 root 2. So therefore distance between point A and point B is 2 root 2. Any question, any queries? Yes sir, no sir?
No, sir.
So this is our first sum. Please write down all these steps clearly. Sum number 2, coordinates of P, point P are -5 and 7, and coordinates of point Q are -1 and 3. So in solution we can say that let coordinates of P we give name as x1, y1, and coordinates of Q we give name them as x2 and y2. So therefore we got here value of x1 is equal to -5, value of y1 is equal to 7, then value of x2 is equal to -1, and value of y2 is equal to 3. Now by distance formula, we can use here now distance formula. As we know, by distance formula we can find the distance PQ. Sorry, that is PQ is equal to x2 minus x1 whole square plus y2 minus y1 whole square and square root of this sum. So therefore now we fill up the values. We can fill up the values that x2 is -1. So -1 minus minus. So here we can take the square bracket first. -1 minus -5, as the negative value of x1 has negative value, we should take the bracket for that, whole square plus, now for y2 y1 they are positive, so we can write down here y2 is 3 minus y1 is 7 whole square. Therefore PQ is equal to PQ, we have now here -1 minus minus plus 5 whole square and plus 3 minus 7 whole square. Step by step we go near the answer. Now -1 and plus 5 we get 4, positive 4. So square of 4 plus 3 and -7, subtraction would be there, answer is -4. So square of -4. So therefore here PQ is equal to 16 plus 16. Okay, positive 4, square of positive 4 is 16, and square of negative 4 is also 16. So here we get, how many times 16 we get? 2 times. So 16 into 2 we get here, or 2 into 16 we can, 2 times 16 we can write down. Therefore PQ is equal to square of 16 we get 4, and square of 2 we get root 2. So here distance between these points, so here we can write down D and comma. Okay, D and comma we can write down, and there is no need to write down the every time PQ, 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 PQ. So where we get the last answer, that step only we can write down distance D for distance. P comma Q means distance between points P and Q is 4.2. Is that clear to you, Purva? Any question, any queries regarding the steps?
No, sir.
Okay, please write down all these steps clearly. So number 3 is going on, in which the coordinates of R are given as 0 and -3, and coordinates of S are given 0 and 5/2. So here we can write down, let point R coordinates x1, y1, and point S coordinates 0 and 5/2. So therefore we get the value of x1 as 0, value of y1 is equal to -3, value of x2 is equal to again 0, and value of y2 is equal to 5/2. So these values we get. It means that these 2 points are on the y-axis. It suggests that as their coordinates, x coordinate is 0, it means they are on the y-axis. So directly we can do the difference between these two y coordinates. But as we have here distance formula. So here we can use distance formula to solve this sum also. So by distance formula, here we get distance d r comma s, distance between r and s are there, and that is the square root, two brackets we can make, that is 0 minus 0 square plus y2 minus y1, 5/2 minus -3, 5/2 and -3. We can write down, we can take the square bracket for them because negative number should be written in the bracket. So here we just take the square bracket for that. Y2 is 5/2 minus y1 is negative, so -3. So that we can do here, and square of that. Okay, so first bracket square we get 0. 0 plus 5/2 minus into minus plus 3 whole square. This we get. Okay, so is equal to, now we take only one bracket, as first bracket answer is 0. So 5 plus 3 2s are 6 whole upon 2 whole square. So here we get 11/2 whole square. 11/2 whole square. Eleven upon t whole square. Distance RS we are going to take. So square root of square. Square root of square we get 11/2. If you find us taking the square root of square, we get the answer 11/2. Is that correct? Yes sir, no sir? So here we get answer distance between point R and S is 11 upon 2. So here we can get the answer here. Distance R S is equal to 11 upon 2 units, as there are no units are given, centimeter, meter or any millimeter is there. So mention the units as the answer. In sum number 4, the coordinates of point L are given as 5 and minus 8. Second point, point M, the coordinates of point M are minus 7 and minus 3. So here we can write down that let L coordinates x1 and y1, and second point M coordinates x2 and y2. So here we get the values of x1 is 5, y1 is negative 8, x2 is negative 7, and y2 is also given negative 3. Okay, so now we can use these values in our formula. So by distance formula, the distance between point L and point M, not S is the point previous sum, L and M, the distance between these 2 points, we can write down. We can take the radical sign here, and x2 is minus 7, so minus 7 minus 5 square plus y2 is minus 3, y1 is also negative, so we can take the square bracket. Y2 is minus 3 and y1 is negative, so minus 3 minus minus 8 whole square. Okay, so first bracket we get minus and minus, both are minus, so we can add them and take as minus 12 square plus, in second bracket we take minus 3 plus 8 whole square, and we have to take the square root of this sum. Now square root of, we get two terms over there, minus 12 square, this is the first term we get, and second term now we get minus 3 plus 8 means positive 5 is the answer of this bracket. Solving the bracket we get that. So now taking the squares of these two numbers and sum of them, 12 minus 12 square is 144, because square is positive, always positive, and square of 5 is 25. So answer of this we get 169, which is the square of 13. Okay, 169, we get the square root of 169, which is the square of 13. So in answer we get 13 units. The distance between point L and point M is given as 13 units. Okay, is that clear to you? Simple steps are there. We should pay attention towards the signs. If signs go wrong, then it may get you go wrong answer. So please look at the signs also. The next sum is sum number 5. Sum number 5 is going on. The coordinates of the T and R are given. Let name them, let T having coordinates x1 and y1, and r coordinates we suppose x2 and y2. So therefore value of x1 we get here, x1 is equal to minus 3, y1 sorry, so here y1 we get 6, then x2 we get 9, and y2 we get minus 10. So therefore by distance formula, here we can write down by distance formula, the distance between point T and R is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So what are the values of x1, y1, x2, y2? So fill up those values here. Next work is there. Fill up the values. So x2 minus x1. x1 is negative. So here we should take square bracket. And x2 is equal to 9. So 9 minus negative 3. Negative 3 should be written in the bracket. y2 minus y1. y2 is minus 10 and y1 is positive 6. So minus 6 square. Need not to draw the square bracket. So now here we solve these brackets. First we get 9 minus plus, so 9 plus 3 whole square. Second bracket both are negative, so we get negative answer. Addition of 10 and 6, negative 16 we get here. So square root of 9 plus 3 is equal to 12. So 12 square plus minus 16 square. So now square of 12 we get 144 and plus minus 16 square. So what is the square of minus 16? Can you tell? 256. Did you get this, Purva? Yes sir, no sir?
Yes, sir.
Okay, so now add them. 100 plus 200, 300, and 44, 56 get 100, so 300 plus 100, 400. We get here 400. So square root of 400 is 20. So distance between 2 points, that is point T and point R. Distance between point T and point R is 20 units. The answer we get here 20 units. And distance will be not negative. So here we do not take the negative square root. So therefore in wording we can write down here the distance between points, distance between points T and R is 20 units. Is 20 units. So box your answer to highlight the answer so that examiner can get the answer properly. So here we use the distance formula and got the proper answer of the sum, that is 20 units. So here we have solved the sums and get the ideas clear how to solve these sums and find the distance between two distinct points. Thank you for watching video, and if you like this video, please subscribe the channel and share this link of the video and this channel to your friends. Thank you again. Goodbye. See you. Have a nice day. Bye bye.